That's still quite a lot of vodka, but here goes. Euler would certainly be a hard act to follow. Mathematicians from two countries would try. Both France and Germany were caught up in the age of revolution that was sweeping Europe in the late 18th century. Both desperately needed mathematicians, but they went about supporting mathematics rather differently. Here in France, the revolution emphasised the usefulness of mathematics. Napoleon recognised that if you were going to have the best military machine, the best weaponry, then you needed the best mathematicians. Napoleon's reforms gave mathematics a big boost, but this was a mathematics that was going to serve society. Here in the German states, the great educationalist Wilhelm von Humboldt was also committed to mathematics, but a mathematics that was detached from the demands of the state and the military. Von Humboldt's educational reforms valued mathematics for its own sake. In France, they got wonderful mathematicians like Joseph Fourier, whose work on sound waves we still benefit from today. MP3 technology is based on Fourier analysis. But in Germany, they got, at least in my opinion, the greatest mathematician ever. Quaint and quiet, the university town of Göttingen may seem like a bit of a backwater. But this little town has been home to some of the giants of maths, including the man who's often described as the prince of mathematics, Carl Friedrich Gauss. Few non-mathematicians, however, seem to know anything about him. Not in Paris. Qui s'appelle Carl Friedrich Gauss? No? Not in Oxford.
I've heard names, but I couldn't tell you.
No idea.
No idea?
No.
And I'm afraid to say, not even in modern Germany.
Me?
No?
Me?
Okay.
I don't know.
You don't know? But in Göttingen, everyone knows who Gauss is. He's the local hero. His father was a stonemason, and it's likely that Gauss would have become one too. But his singular talent was recognised by his mother, and she helped ensure that he received the best possible education.
Every few years in the news you hear about a new prodigy who's passed their A-levels at 10, gone to university at 12, but nobody compares to Gauss. Already at the age of 12, he was criticising Euclid's geometry. At 15, he discovered a new pattern in prime numbers which had eluded mathematicians for 2,000 years. And at 19, he discovered a construction of a 17-sided figure which nobody had known before this time.
His early successes encouraged Gauss to keep a diary. Here at the University of Göttingen, you can still read it, if you can understand Latin. Fortunately, I had help.
The first entry is in 1796.
Is it possible to lift it up?
Yes, but be careful.
Yeah,
It's really one of the most valuable things that this library possesses.
I can believe that.
He writes beautifully.
It is aesthetically very pleasing, even if people don't understand what this is. It is just beautiful to look at. So, I'm going to put this down, actually. It's very delicate. Yes. The diary proves that some of Gauss's ideas were 100 years ahead of their time. And here are some signs and
these
integrals.
Sort of integrals.
Very different sort of mathematics.
This was the first intimations of the theory of elliptic functions, which was one of his other great developments.
So there's already getting very sophisticated.
And here you see something that is basically the Riemann zeta function appearing.
Wow,
here.
Gosh. That's very impressive. The zeta function has become a vital element in our present understanding of the distribution of the building blocks of all numbers, the primes.
There is somewhere in the diary here where he says, I've made this wonderful discovery, and incidentally a son was born today.
We see his priorities.
Yes, indeed.
I think I know a few mathematicians like that too. Yes. My priorities, though, for the rest of the afternoon were clear. I needed another walk. Fortunately, Göttingen is surrounded by good woodland trails. It was a perfect setting for me to think more about Gauss's discoveries. Gauss's mathematics has touched many parts of the mathematical world, but I'm going to just choose one of them, a fun one, imaginary numbers. In the 16th and 17th century, European mathematicians imagined the square root of -1 and gave it the symbol I. They didn't like it much, but it solved equations that couldn't be solved any other way.
Imaginary numbers have helped us to understand radio waves, to build bridges and aeroplanes. They're even the key to quantum physics, the science of the subatomic world. They've provided a map to see how things really are.
But back in the early 19th century, they had no map, no picture of how imaginary numbers connected with real numbers.
Where is this new number? There's no room on the number line for the square root of -1. I've got the positive numbers running out here, the negative numbers running here.
The great step is to create a new direction of numbers, perpendicular to the number line. And that's where the square root of -1 is. Gauss was not the first to come up with this two-dimensional picture of numbers, but he was the first person to explain it all clearly. He gave people a picture to understand how imaginary numbers worked. And once they developed this picture, their immense potential could really be unleashed.
Morgen, ein Kaffee bitte? Yes, thank you.
His maths led to acclaim and financial security for Gauss. He could have gone anywhere, but he was happy enough to settle down and spend the rest of his life in sleepy Göttingen. Unfortunately, as his fame developed, so his character deteriorated. A naturally conservative, shy man, he became increasingly distrustful and grumpy.
Many young mathematicians across Europe regarded Gauss as a god, and they would send in their theorems, their conjectures, even some proofs. But most of the time he wouldn't respond, and even when he did, it was generally to say either they got it wrong or he'd proved it already.
His dismissal or lack of interest in the work of lesser mortals sometimes discouraged some very talented mathematicians from pursuing their ideas. But occasionally, Gauss also failed to follow up on his own insights, including one very important insight that might have transformed the mathematics of his time. 15 kilometres outside Göttingen stands what is known today as the Gauss Tower.
Wow, that is stunning.
It is
What a
really a
view.
fantastic view here, yes.
Gauss took on many projects for the Hanoverian government, including the first proper survey of all the lands of Hanover.
Now, was this Gauss's choice to do this surveying? I mean, for a mathematician, it sounds like the last thing I'd want to do. But
He wanted to do it. The major point in doing this was to discover the shape of the Earth.
But he also started speculating about something even more revolutionary, the shape of space.
So he's thinking, you know, there may not be anything flat
Yes,
in the,
yes, exactly.
in the universe. And,
Exactly.
Ah.
And if we were living in a curved universe, there wouldn't be anything flat.
And this led Gauss to question one of the central tenets of mathematics, Euclid's geometry. He realised that this geometry, far from universal, depended on the idea of space as flat. It just didn't apply to a universe that was curved. But in the early 19th century, Euclid's geometry was seen as God-given, and Gauss didn't want any trouble. So he never published anything. Another mathematician, though, had no such fears. In mathematics, it's often